Hi, Year 13 BTEC. Here we are finishing our teaching of uh, D1 assessment criteria, which is for Unit 26, Assignment 3, Number System. Now, a couple of weeks ago, on Excel Day, we managed to do D1, finish the D1 teaching, about two-thirds of D1 teaching. We managed to do our assignment. We finished question 1, our assignment for D1, question 1, question 2, question 3, and question 4. Now, what we left to do is question 5 and question 6. Okay. Now, I must say, before you tackle question 5 and 6, you must do question 1, 2, 3, and 4, because question 1, 2, 3, and 4 will give you some knowledge about networking and also some network keywords, terminology, definition, and explanation. With this basic understanding of a network and the some keywords explanation, then only you can do question 5 and question 6. Now, question 5 and question 6 are very similar in nature. um, I will guide you through in this video doing question 5, and then you are left by yourself to do question 6 um, on your own. Now, notice also in question 6, you have to justify your answers. Yeah, justify your calculation. You have to explain um, how did you get these answers. These are your answers. How did you get it? Why do you add? Why do you subtract or multiply in any way? Okay, and which formula did you use to get the answers? Yeah. Okay, so let me just scroll up a bit, make it a bit bigger for you to see. Now, just remind you, question 1, this is question 1 here. And let me scroll down, question 2 and question 3 and question 4. Now, to do question 1, 2, 3, and 4, for those of you who didn't attend Excel Day, so you just need to watch this YouTube video, which is very short. It's a 5 minutes video clip. Uh, uh, 5 minutes video clip, and here from this video clip it will give you all the answers that you need for question 1, 2, 3, and 4. Okay, now this video clip, the web address, you can get it from uh this Word document which I emailed it to you, and so that is the web address here. Okay, I bullet point I bullet point to those videos that which I think is are quite um nice and quite useful for you to watch. They are very short video clip, and I felt the speaker in this video, they are very clear in their explanation, and they are very short video. The speaker also speak clearly and straight to the point, so it's easy for you to um to understand. Okay, so this is first video for question 1, 2, 2, 3, 4. For question 5 and 6, if you have time, and you can also watch this video, classless interdomain routing, which is this one. Okay, and also this is 13 minutes, and then you have this one, classless subnetting, which is this video, the third bullet point. Okay, and
Classless
also you
subnetting,
have,
classless interdomain.
let's turn it off. And also you have this one, again, how find the number of subnets, how to create an addressing scheme, which is I think is this one. Yes, the fourth video clip with the bullet point, and also this one as well. This one is a bit longer. How long is it? This is about 16 minutes. Okay, which is this one, the last one, the fifth bullet point. You don't have to watch all of them because they are all talking about a similar topic, how to create an addressing scheme, and what is CEDAR, classless interdomain routing. Now here, let's come back to our PowerPoint. Now, D1. Our focus in this video is question 5 and 6. So our learning objective is to understand CEDAR or CIDR, whatever way you want to pronounce it, classless interdomain routing method in order to design a network addressing scheme. Okay, so the outcome of this video, I hope that you should be able to understand what is subnetting, why subnetting a network, and you should be able to design a network addressing scheme using the CEDAR method. This is question 5 and 6, and you should be able to justify your work, your design network addressing scheme to your client. This will be question 6. Okay, so you have to justify your answers to your client. You have to justify and say why the network addressing scheme that you have designed, you have created, is appropriate to your client, is suitable to your client's needs. Okay, so that's for question 6, which you have to answer it yourself. Now let's come back to, okay, let's go to, right, let's go straight to the question, shall we? Yes, and I think we should. um that is it. Okay, let's look at our question. um Right. Okay. Before we start question 5, I think we should talk about subnetting. What is subnetting? Basically, subnetting is you divide a big network into a smaller network, into a few smaller subnetwork. So here, your client give you a, a a big network, and then you divide this bigger network into a few or a subnetwork. Okay, so this is called subnetting. Depends on your client's needs. Yeah, what they want you to do. Now, why subnetting a network? Why do you want to divide a big network into a few smaller network? Why do you want to do that? Basically, subnetting is you want to you want to use every single IP address given in a network. Basically, you don't want to waste any IP address. Okay, so just think about why subnetting a network is about saving space on a bookshelf. If you have a bookcase and on the shelves is full of books, so I would say you have used this bookcase um, very well, because there's no gaps between the books, because all the bookcase is full of books. Okay, you haven't wasted any storage space. But if you have a bookcase and you just put in some books, and then you come to me and say, this bookcase, I ran out of a bookcase. I need more bookshelves. But that's not quite true, because I can clearly see there are gaps in between the books, which you can put some more books. You're wasting the storage space. So you're not utilize your bookcase um, very well. Okay, you didn't pack your bookcase with full of books with no gaps in between books. So therefore, the reason why you're subnetting a network is exactly the same. Right. Let's look at question 5. Okay, so this is a very simple scenario. Based on the information below, design a network addressing scheme that will supply the minimum number of subnets and valid usable host for use in an organization. So your client is this organization, is an imaginary organization, okay, and ask you to do this. They told you, well, I want this network. My network address starting is this one, 192.10.10.0, and I want 14 subnets work. So he wants a 14 a smaller network, and each of these network will have can assign to 14 usable hosts. That means you can give it to 14 usable computing device. You have 14 IP address, can give it to 14 ICT device. Now let's do the max here. Let's get up the my calculator. Where's my calculator? There. Is this my calculator? Okay, my calculator. It says here. Um, my client wants 14 smaller network, and each of these smaller network, we call it subnet. Each subnet must can have 14 computing device. Okay, so in total, how many IP address I need for the amount of the number of computing device he needs? Now, which means he will need to have 196. He will need to have 196 computing devices, or maybe 196 computers, maybe some of them is printers. Then you need 196 IP address for these 196 ICT equipments, isn't it? Now we on our okay on Excel day we discuss class A, B, and C. Okay, so the classes of network with class A, B, C. A being the biggest, B is a medium size, C is kind of the smaller network. Okay, and we did say here. Let's see. Right. Okay. Yeah. Here. Class C network. Class C network allowed the maximum 254 uh, uh, IP address can assign to, well, 254 um, computing devices. Okay, now 254. Now my clients only need 196. Okay, now you may say, oh, that's very easy. Why can't we just assign the class C network to our client? Because within class C network, my client can have up to 254 IP address available to assign to his to the ICT equipment that he wants. But my client currently he only need 196. Now just do the max. 254 254 hosts minus 19600, which is what my client needs. So which means you have 58 IP address lay idle and is not used, and it's not assigned to um, any ICT equipments, any computing equipments. So it's just like the bookcase example I tried to illustrate earlier. You have kind of 58 storage space that's of 58 gaps in between the books that's lying idle, which you can put more books in here. You have 58 IP address laying there wasted, whereas this 58 you can add to another 58 computing devices. and we don't want that. We don't want IP address lying idle and not assigned to any ICT equipment. We want to utilize all the IP address as much uh, as possible, assigned to all ICT equipment. Okay, now that's how we'll do it. Okay, let's minimize this. Now this, let's work out this. To work out this, we use this to work this out. Okay, now that is it. First of all, you need to find out uh to design the addressing scheme, which is this one. We need to identify the address class. Now you need to see what is the network address class here. Okay, and you look at it, this network address class start with 192, and you wonder, is it class A, B, or C? Now remember, we when we watch this video, yep, we have learned that class A, B, C, the first part of the IP address for class A, it will be it will start between 1 to 126. Now if you look at this, number, let me make it bigger. Okay, if you look at the first part of the IP address here, is it 192? Does it fall in between 1 to 126? No, it doesn't. Now, is this a class B a class B address class? If you look at here, one class B address class fall in between the first part of the IP address. It falls in between 128 to 191. But if you look at this IP address here, 192, no, it just falls just right outside class B address. So now we look at the class C address. Okay. Oh, sorry. Now, class C address. Now, the first part of the class C address, it will fall in between 192 to 223. Now, look at this one. It just nice to fit into class C, because class C start with the 192 number. So therefore, we are comfortably say this is a class C address. So we can put the word class C here. Okay. So default subnet mask. Now I'm not going into explaining default subnet mask, but when we did question 1 to 4, we understand that default subnet mask is the IP address that can separate the network ID and the host ID. Okay, let me repeat. The default subnet mask is to separate, can be applied to an IP address in order to separate the network ID from the host ID. And just like this one. So now the default subnet mask, okay, for class A is this one, 255.0.0.0. For class B is 255.255.0.0, and for class C is 255.255.255.0. Now this is the decimal number. It's a normal number how we write it. If you want to write the default subnet mask for class C, it will be in binary. It will be uh 8 ones, and then 8 ones, 8 ones, and 8 zero. Why 8 ones? Obviously, uh, 8 ones will come to the binary 8 binary 1 will give you the number 255. If those of you who have forgotten how binary works and binary conversion, which Miss Sangani has taught you. Now that's the thing. So by these are the decimal number, which is the normal number we have, normal 1 2 3 4 5, and this is a binary. By means 2. So binary number you only have two digits, 0 and 1. And denary is 10. You can have up to 10 digits from 0 to 9. Now binary, to get to the next one, is times 2, multiply 2. So it's 1, 2 times 1 is 2, 2 times 2 is 4, 4 times 2 is 8. And as you go up, 64 times 2, you get 128. So to get 255, you need to add all these number together. So therefore, it will switch to 11111111. It gives you 1 byte, 8 bits. Okay. So let's go back to here. Right. Okay. Now here, now the default subnet mask, it will be 255.255.255.0. Why? Yep, it's because this is the default subnet mask for class C address. And we know, and here we give our answer, class C. Okay, so this is class C address, default subnet mask. Now we come to this one, very strange one, custom subnet mask. Custom means we must have done something to this default subnet mask to alter it a bit so that it will suit our needs, or rather I would say to suit the client needs. Okay, this is what our client wants, so we custom it. Why do we custom it? Basically it comes to what I said before. You don't want to waste. Yeah, let's bring back the calculator. You don't want to waste all the IP address. Can you see here? If we just give our client class C address, uh, it will be wasted 58 um, IP address lying idle. So it's not used. So that's why we want to custom it. Now, okay, default subnet mask. Uh, Let me give the answer. Okay, default subnet. Now, okay, right, okay. Aha, I have this ready. So I'll put it down here nicely. Um, Default subnet mask here in the decimal. And I also here default subnet mask in the binary. Okay, so I just explain it to you here. My network ID is in blue and the host ID is in green. Just to reiterate, the network ID here in blue will identify the area where your network is. Maybe your area is in London or Manchester, Birmingham, whatever. Now here, the green one is a host ID. Host ID means it's the ICT equipment. This is the IP address for your ICT equipment. Could be the printer, could be a network scanner, and or network computers right here. Now, what do we do next? Next, this is what we do. Okay. Now, in order to do this, we in order to work through this, we have done a bit of this. We are actually in a process of subnetting here. Okay, the process of creating the address scheme. First of all, we need to classify the address, which I just done here. Uh, the address is class C. Okay, and what are your needs? What my client wants? I understand what my client wants. My client wants 14 smaller network, and each of these, oh, my client wants 14 smaller networks, which each of these networks, with small network, will need 14 usable hosts. That means 14 host ID here. My host ID, 14 IP address. That's what he wants. Okay, right. And then after that, the next thing you do, you need to create a subnet mask. Okay, can you see? Create a custom subnet mask, which is what can you see? Create a custom subnet mask. Okay, so this is what we are going to do. After you've done step 3, create a custom subnet mask. Now you can do the step 4. Determine your subnet range as well as the network address, the first IP address, the last IP address, and the broadcast address for each of the subnets. So this one will be, it will be here, it will be all this. Okay, it will be filling up this table. Yep, showing the addressing scheme here. Now subnet ID. Now now subnet ID is this. This is the your original subnet mask. Now you can see this one is not the class C subnet default subnet mask. Those of you who are very clever, you will you can guess this is class B, because class B is 255.255.0.0. Let's show you the, okay, that's the, okay, see class B. Now let's go back here. Now subnetting a custom create custom subnet mask is very easy, and it's very clever as well. What happened is, in order to save the IP address, we use this seeder system, which is a classless interdomain routing. Why classless? Class Classless, which means this class of network doesn't belong to class A or class B or class C. That's why it is called classless. Okay, look at here. Yeah, classless. Um, so now there's a point here. This is the network ID for the to identify the network area where your network come from. Now this is a host ID. Host ID is the available binary digit to assign to your IP address. Right now you have uh, 16 binary, which is quite a lot. Okay, so now if we don't want that much, we want to reduce the number of IP address, all we need to do is move this point here to wherever you want, according to whatever your client's needs is. Then you assign the host ID. You are restricting, basically you are reducing the number of IP address that needed for your clients. For example, in this one, this is without subnetting. This is a default subnet mask, but this is with subnetting. Now I move this bar, this pink bar, I move it to here. So therefore, I'm giving one. So this is my subnet ID. The subnet ID is in the binary digit in in orange here. So I'm having 1, 2, 3, 4, 5, five five binary one to be subnet ID, and this 5 binary 1 I'm given it to become the network ID. So the network ID originally, instead of having 8, 8, 16, so now the network ID is 16 plus 16, 17, 18, 19, 20, 21. So these 21 binary digits, they're all in ones, they are our network ID. But the host ID, I can only have, here is 8, 8 plus 9, 10, 11. Instead of having the original 16 uh, binary digit for the host ID. Now I only have 11 digit for the host ID, which reduce the number of IP address I can have. Well, now this is good, which means you are saving um, the the idle IP address that you are not utilized, which is in our case you are saving the 58 IP address that's not utilized. Now, how this is done, you will take your our question 5, the subnet ID that we have, and then we have um we have formula. Okay, now the number of subnets, okay, is 2 to the power of n is the number of ones in the subnet ID. So let's say, for example, here my subnet ID is 1 2 3 4 5, this 5 orange one. So therefore my the total number of subnet I could have is 2 to the power of 5. Okay, and the number of available host ID for each of these subnet is n is equal to number of 0 in the host ID. Now here in this example will be 1 2 3 4 5 6 7 8 9 10 11 11 0 11 host ID. So therefore you will have 2 to the power of 11 minus 2. Okay, yeah. Now let's come back to now here. This is this example I just given here. Now can you see 2 to the power of 5 will give you 32 subnets, which is 32 smaller network. 2 to the power of 11 minus 2 will give you 2046 available host ID in each subnet. That means each smaller network. So each smaller network can have 2046 IP address or 2046 ICT uh, uh, equipment you can have. Okay, now we'll come back to this here. Right, okay, subnet ID. Let's see here. Now I've done this. Um, Okay. Now in our question 5 here, the subnet ID we need is this. Okay. I'm going to borrow 4 bits. Okay. I'm going to borrow 4 bits. This is my subnet ID. My subnet ID I show it in red. Okay. Now this is my original custom sorry, this is my original default subnet mask. Now my custom subnet mask is this. I borrow 4 bits. Okay, so which means from now on, oh wait, let's put a space here. From now on, this will be my network ID to identify my network area, and this will be this 0 will be for the host. Okay, now so this will be my custom subnet mask. Let's see, I prepare my answer here. Yes. Okay, let's put it here, copy and paste. Right, okay. Right, okay, never mind. So therefore, can you see this? My custom subnet mask is this one. Okay, yep. Okay, now yeah. So now can you see this one? I also show you the denary number. Can you see the first 8 bits? 81 become 255, but here 41 and 40 become 240. For those of you who still can't remember about how binary converts into denary numbers convert into binary number, there you go. I'll show you here. If you have 4 ones, um, on the left and 40. Okay, which means those with 1 is this 128 plus 64 plus 32 plus 16 will give you 240. So this the whole thing is actually represented by is the number 240. So that's how 240 comes from. So my custom subnet mask is 255.255.255.240. Okay, so this one as compared to the original default subnet mask. No, now I have got a custom subnet mask. Now I go to do my formula. Now I want the total number of subnets. Let's go back to our PowerPoint. The formula is this 2n. Yeah, n is the number of ones. Okay, how many ones we have here? 1, 2, 3, 4. So which means is 2 to the power of 4. So what's the answer? 16. You give me 16, 16 subnets. Let's see. Yes, this is all done and prepared. All I need to do is copy and paste. There you go, 2n, where n is equal to number of ones in the subnet ID. Can you see? My subnet ID is in red color. This is my subnet ID. Okay. So it will give me 16 subnets for my client. Is it good enough? If you ask this question, is it good enough? Yes, I think it's good enough because my client he only wants 14 subnets, 14 smaller network. But now I can give him 16 smaller network with two smaller network uh, spare. So I think that is good enough. Okay. So now the last bit. Okay, this is very easy to do, which is we apply this formula 2 to the power of n minus 2, where n equal to the number of 0 in the host ID. Okay, it's very uh you must remember this. The host ID is this one. Okay, in green. So how many 0 have I got in green? Just count 1, 2, 3, 4. So it's 2 to the power of 4 minus 2. That will give you 16 minus 2 will give you 14. Yes, I have just enough 14 host ID for my clients. So I again I have prepared my answer here. Haha. So there you go here. We have 2 to the power of n minus 2. We know n is 4 because I have 4 0 here. So 2 to the power of 4 minus 2 will give me 16 minus 2, 14. So that means I can give them each subnet 14. Is it good enough? Yes, it's just enough. 14 host ID in each of these uh, s- uh, subnets. Each of these smaller network. Okay, so now I can fill this up now easily. The custom subnet mask is this one. Now I'm not so fuss about uh, what you what you give me as long as is correct. Some people choose to give me subnet mask in binary form 11100 and so on. Some choose to give right the custom subnet mask in binary form, which is the number that we have every day. um I that's okay to me. The total subnets I have, I can from my calculation is 16, and the total number of usable hosts is 14. And subnet ID, number of bits borrowed. How many bits I borrow? 4. Can you see? I borrow 4 bits here. So the total number of bits borrowed is 4. Okay. Now usable host. Okay, now come back to this usable host thing. Okay. Now, those of you who have done question 1 to 4 on Excel Day, we you you understand that there are two address in the network. We cannot use it. They are called reserve. They are reserved for other purpose. Okay, they are reserved address, and this is and they are called the network address and the broadcast address. You don't need to know what they do for your level, for your BTEC level. All you need to know that the network address is an IP address in which the host ID is set to 0. Okay, basically this is the first IP address. Okay, and the broadcast address, an IP address in which the host ID is set to 255. So the binary is 8 bits. So which means broadcast address is the last address. So here you have the network address being the first, and then you have the broadcast address being the last. Okay, so that's why this formula, if some of you will ask why the number of available host address is 2 to the power of n minus 2, because minus 2, this 2 is reserved for uh, network address and broadcast address. These two addresses cannot be used, so therefore the number of usable host address, or the usable IP address, is minus 2. Is always minus 2, because you cannot assign network address and broadcast address to any ICT equipment, any network computing equipment. Okay, so now we've done this. Ha ha ha. Now we come to this. Now this is easy. This is easy. We start with 0. Okay, and then we start with 1, and then 2, and because we want 14, so therefore we 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, and 13. We stop at 13. We don't need 14. Why do we need 14? Because we just want 14 uh, uh, subnet. So 14 small network. So from 0 to 13 will give us 14. You have to count 0. So you from 1 network until here 13 network plus the 0 here. So here we just have enough 14 network. So we can just come up to here. That's all we need. Now the subnet ID, okay. This subnet ID is in a binary. So okay. Now because we borrow four digit, 4 bits for subnet ID. Okay. So therefore here our binary subnet ID is also 4 bits here. So this is 0. Uh, and this is 0001, and this is 0 0 0 oh, 1 0. It will give us 2. To give us a 3 will be 0011, and to give us a 4, 0100, and to give us a 5 will be 1. There's a 451. Am I right? 4 plus 1 is 5. So to give us a 6 will be 0111. So 4 plus 4, oh, no, 0. So 4 plus 2 here is 0. So for 7 will be, okay. So here will be 4 plus 2 is 6, plus 1 is 7. Now I let you work it out yourself from 8 to 13. You know what to do. Now the first IP address is, now now you come up here. the first IP address. This is what your client gives you. Okay, 192.10.10.0. So therefore, we'll put 192.10.10.0. 192.10.10.10.0. Okay, and now each subnet now did all this is a small network. All this is the small network here. All this network can have 16 IP address with 14 only can be used. So therefore here the first IP address being 0, the last one will be to 15 because that will give you 16. Am I correct to say? Yeah. So 192.10.10.0, 192.10. So you have 1 to 15 computers plus the 0 here. It will give you 16 host ID. Yeah, which is this one, 16 host ID. Okay. Yep, I haven't minus a 2 here, but we'll come to that later. So then for the second network, it will be like this. Oops, so no, it shouldn't be paste, it should be copy. It should be copy and paste here. No, the next one up is 16. Okay, the network net 16, and this one will be 32 or 31. Okay, and then the next okay, paste it. uh 32, and then the next one up is 33, and so on. Okay, so now but I am really 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 too lazy to work out the rest, so I'll just show you. I'll just show you. Mm, 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 right, okay. Question 5. Right, okay. Let's zoom zoom it. Okay. Oh, I work up to 15, but these two you don't need it. Let me just gray it out. Let me just uh okay, I put it in yellow or put it orange. You don't need it. Okay. Right, okay. Now, so can you see 0 to 15? That will give you 16 IP address. This is the first network, small network. The second small network will start from the IP address 16 and up to 31. Sorry, 16. Oh, that is 31. So it's 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Yes, it's 31. Sorry, guys. So it should be 31. Sometimes count it with your fingers is good. 32. Okay, and so in between these will give you 16 IP address. So of course the third smaller network will start with 32 because it's 31 here, so it's 32. And then between 32 and 47 will give you 16 IP address. Okay, and it's all the way up to the 13 subnet here. Okay, so you get it done yourself. Now for this one, okay, this is very easy. Now the first, remember we said network address is is always 0. So oh dear, this is the first one. And then we have the last IP address here. That will be your broadcast address. Remember here we have 16. Here we'll give you 16 IP address. And remember, the 16 IP address, only 14 is usable. Okay? The reason being is you can guess, because the first and the last IP address is network address and broadcast address. So therefore here the usable IP address is this. Okay? First usable IP address is this one, and the last usable IP address is this one. So therefore, you of course, in between you can use them. For example, 192.10.10.2 and 192.10.10.3, 192.10.10.4. These are all usable IP address which you can assign to any ICT network equipment here. Okay. Now here, subnet number. Oh, this is the first one, the first subnet, and then here you have uh uh this. Okay. Oh no, no, I subnet number, I rather put it in decimal. Sorry, not decimal, binary. So this is the second one, 001. Okay. Okay. Yeah. And right, subnet address with CIDR notation. This is um right, because our subnet ID, because we change the default subnet mask into custom subnet mask, which is this one, and we have borrowed 4 bits from the host ID to become the network ID. So therefore, the network ID here for question 5, instead of having 24 bits here, the original 24 bits here, hey, 8, each one of these is 8 bits. So 8 times 3 will give you 24. So 24, 25, 26, 27, 28. So therefore, our CIDR notation will become something like stroke 28. Okay. So now here I have the prepare answer here. Oh, 0 stroke 28. Okay, so now can you see that you cannot construct this diagram without finishing this diagram. So otherwise it'll be quite confusing to do. So can you see that here it's coming from the first row, and then the second row here come from the second row, which is 192.10.16 to 192.10.31. And then for this one, the next first usable IP address will be 192.10.10.17. And then the last usable IP address is, of course, 192.10.10.30. And then the next one will be the broadcast address. And then for the subnet number, the subnet number, second, this is the uh third smaller network, third subnet, 192.10.10.32. So I have here .10.32 here. Okay, and then here the third subnet, the last IP address is 192.10.47. I also have here 192.10.10.47, and in between the first address and the last address, we have 192.10.10.32. Sorry, not dot 32. Dot, this will be 33. Okay, and then this one will be 192.10.10.46, and after the 46, you have 47. Okay, so I let you to have a look here, and that's we finish. And now, as for you, you will need to finish question 6. This is your question 6. Okay, read it, and then you fill up this, just like you, and then you can fill up this, and then after you have worked out the information, then you justify how do you get your calculation, and you have to justify whether your calculation, the number of subnets and the number of usable host ID are enough for your um, client's needs. Okay, so which is this. Yep. Oh, this is what your client needs. Okay, right. And thank you, year 13. Thank you for your patience. Thank you for um uh watching this video and listening. Bye.